Welcome back to ME 760, Engineering Analysis 1. So last time we discussed the vector analysis. Welcome back to ME 760, Engineering Analysis 1. Last time we discussed the vector analysis. And we discussed also the multiplication of vectors, and we stated that we have 4 types of multiplication for vectors. The first one is the dot product, the vector dot product. Today we will go over the other 3 types of vector multiplication. They are the vector products, and there is the triple product, scalar triple products, and then the last one is the vector triple product. So let's start. So vector, or sometimes they call it scalar product. And usually they give it symbols A cross B. And usually the scalar product is defined as if we have a vector A crossed with vector B, and let's assume that this is vector A, this is vector B. So the cross product, there is an angle between vector A and vector B, and this angle is theta. So the cross product will be a vector, let's say C, which is perpendicular to both A and B. And you have to conserve the right-hand side rule. So when you do the vector product, you said product of A and B, so you go from A to B along the shortest path. You do not go from A to B this way. You have to go through the shortest path, and then your thumb will give you the direction of the vector product, and it will be C. So it's just a vector perpendicular to both vectors A and B. So how we'll evaluate it? So it is the absolute value or the amplitude of vector A multiplied by the amplitude of vector B multiplied by the sine of the theta or angle between A and B. And also it can be written as A cross B in a matrix format, and this is what we'll be studying in the next chapter for matrix algebra. So when you do the matrix, you will write the components, let's say in Cartesian coordinates. So the components will be I, J, K, and then you write the vector component. So you write the first component of vector A, so this will be AX, AY, and AZ. Then the component of vector B are BX, BY, and BZ. When you decompose or evaluate this determinant, it will be the following. You will get I first with the sign of I. The sign of I is plus, negative here, plus here. Then you will say AX multiplied by, then you will cross those 2 lines, and you will say this is AY multiplied by BZ, so this is the first operation, then by multiplied by az, and this is the second operation. So it will be ay bz minus az by. Then you have minus j, which is the j component, and then you have to cross everything here and here, so it will be ax bz minus az multiplied by bx. Then you will get the third component, which is plus k, and it will be ax by minus ay bx. So this is how to perform the scalar multiplication. So you will get it either a multiplied by b, the amplitudes, multiplied by the sine of the angle theta between the two vectors, or you will decompose the determinants to its components. So there is a couple of properties that we have to take into consideration when we look at the vector triple product. The first one is the vector product is distributive over addition. What does it mean? It means that if you have a vector A plus vector B, and then you cross them with a vector C, this will give you A crossed with vector C plus B crossed with vector C. So this is the distribution property. The second property is what we call anti-commutative. What does it mean? It means that if we have A crossed with B is equal to B crossed with A. So it's not like the scalar product that we studied last time, which is A dot B equal to B dot A. So you can exchange the order without any exchange in the direction. But if you look at here, A cross B will give you this direction. Yes? But when you do the reverse, B cross A will be in the negative direction. So in this case, in order to make them equal to each other, you have to flip the sign so that you will revert this in the other direction. Or if you multiply B with A, the multiplication will be in this direction. In order to give it in the other direction, you have to multiply by a negative sign. So this is the anti-commutative. The third one is it is non-associative. What do we mean by non-associative? We mean that vector A crossed with vector B, if they are crossed with another vector C, it does not mean that A is crossed with B crossed with C. So you cannot have the same association like last time in dot products. So A cross B crossed with C is a vector which is completely different from A cross B crossed with C. So this is, we will see it here in the vector triple product in a minute or so, but before the end of this class. Now, if we have A cross B is equal to 0, what does it mean? It means that the sine theta is equal to 0. What's the sine of the angle that's equal to 0? 0, because the sine, if you do not remember, just remember that this is the sine, and remember that this is the cosine. So you know that at 0, sine theta is equal, sine 0 is 0, and cosine 0 is 1. So this means that the vector A is parallel to the vector B, or anti-parallel. They are either parallel or anti-parallel. Of course, if you cross the vector A with itself, you should get 0. Yes? Now, what's the geometrical interpretation of the vector products between two vectors? So let's discuss some applications for vector or cross product. So if we have a vector A and another vector B, so if you make the same vector here B, and this is the same vector A, so this is something like a square or a rectangle. So the area of this parallelogram, area of the parallelogram A, let's assume that this is the area A, with sides A and B. The sides are contained between vector A and B, is given by the area A is nothing more than A crossed with B, but this is the amplitude. Why? Because let's assume that this is not a perfect square. So let's say that it is parallelogram. So if you want to calculate the area will be just the base multiplied by the elevation, which is in this case h. So the base is what? Is A, and the elevation is what? Is h. So what's h? B sine theta. And because we use A and B, and those are the amplitudes of the vector. So this is just what? This is just the amplitude of vector A multiplied by the amplitude of vector B multiplied by sine theta, which is nothing more than A cross B. So, did you have any question here? Another application will be when you evaluate the moment of torque about point O. So if we have, this is the origin here, point O, and let's assume that we have a force that's acting in this direction, and this is the perpendicular to the force. which is point P, for example, and we want to calculate the torque here, and this is point R, and the position vector is R, and this is the position vector is B, for example. So the torque is nothing more than R crossed with F. So the torque is just F multiplied by the amplitude of F multiplied by the amplitude of R multiplied by sine of the angle theta. Another example, if you have a rotating disc, and let's say that this is R and the disc R is rotating with an angular speed omega. In this case, it has a vector direction for the angular velocity, and we want to calculate, for example, the transitional velocity V or tangential velocity V. So this radius here is R, and what's R? This radius R is small r sine theta, and this is in this triangle r sine theta. And then if we want to calculate the velocity V, is nothing more than omega multiplied by d or r here. So it will be equal to omega multiplied by r is just a small r multiplied by sine theta. So in this case, V is nothing more than omega cross r. Of course, r small. So the vector omega is in this direction and r is in this direction, and it will give you the vector V perpendicular to both. Now let's look for Cartesian coordinates. For Cartesian coordinate, again, like what we did last time for the vector scalar product, if we have x here coming to y, this is z, and we stated last time that we have a unit vector I in the direction of x, and another unit vector j in the direction of y, and another unit vector k in the direction of z. So those are the three unit vectors. So I crossed with I is equal to J crossed with J is equal to K crossed with K. What do you expect the results to be? Do you think it's 1? 0. 0, because the angle is what? 0, and sine 0 is 0. It's 1 in the vector products. So let's assume let's assume that also I crossed with J. This will give us negative J crossed with I. And this will give us what? The vector K. Why? If you look here, I crossed with J. I goes with J. It's 1 by 1. And it gives us what vector? Vector K. It's 1, and it's in the direction of what direction? Z. So again, if you do J crossed with what? With K, this will give you a negative K because they are anti-commutative. So K minus K crossed with J, and this is equal to what? I. What about K crossed with I? This will give you a negative I crossed with K, and this will give you what vector? J. Do you have any questions so far? Now we will move on and we'll look at the triple product. And again, the triple product has two representation. One is scalar triple product and the other one is vector triple product. And what do we mean by triple product? Three vectors multiplied by each other. So look at triple product. Triple product. So the first one is scalar triple product. So how we define the scalar triple product? We'll define a vector A and a vector B and a vector C. And this will be A crossed with B, then the resultant of A cross B will be crossed with what? With C. Oh, sorry. Will be dotted with C because this is the scalar, not the vector. So you multiply, let's say, vector A and then vector B, and then you have another vector. A cross B will give you what? Let's say that this is called vector D, which is the multiplication of A and B, and it is perpendicular to both B and A. Let's assume that the vector C will be somewhere like this. So the multiplication dot product will be the dot product between D and C, which will be dc cosine cosine the angle between them here. Let's say that this is phi and this is theta. Okay, so D is what? A, B, sine phi, yes? And D cross C will be DC cosine theta. DC cosine theta, which will be D is A, B sine phi multiplied by C cosine phi, or this will be A, B, C sine phi cosine theta. Cosine theta. Of course, this is, we knew that this is vector and this is vector and this is the dot product. We knew that the dot product is what? Commutative. Yes, the dot product is commutative. So we can flip the direction and it will be C dotted with what? A cross B. Because this is a vector and this is a vector, and the dot product between both is commutative, so we can exchange it. And again, the evaluation of this will be the vector Cx, Cy, Cz if we start with this one. And then you will have the components of Ax, Ay, Az, Bx, By, Bz. Somebody will ask, what is the components I, J, K? What we will say? Yeah, because this is a scalar product. This is a scalar. This is a vector. Dotted with vector will give you a scalar, so you do not expect that you will see I, J, K, because this is no longer a vector. Yes. So when you just decompose this determinant, you will not get any I, J, K. It will be a scalar quantity. So if you try to do it, just do A cross B will be I, J, K. Yes. Components of A, components of B. Then when you compose this, you will get something in the I direction plus something in the J direction plus something in the K direction. All of this is dotted with Cx in the I plus Cy in the J plus Cz in the K. Then what will happen? I with I will give you 1, and then you will have Cx multiplied by this determinant, subdeterminant here. And then J with J will give you what? 1, and this will be Cy multiplied by something here. And then K with K will be 1, and Cz will be multiplied by this. So you will replace the I, J, K by Cx, Cy, Cz. And of course, if somebody asks, I dotted with J is what? 0, because they are perpendicular. J dotted with I and K is 0, and K dotted with I and J is 0. So what does it mean, the vector triple product? What's the geometrical meaning? So what's the geometrical meaning? If we have 3 vectors, now here is vector B, and this is vector A. This is vector B and A. Then if you just draw the parallelogram again, this will be vector B again, and this is A. Now, if you have vector C, let's assume that vector C is in this direction. And now, again close this one. So this is what? A barrel pipe. Yes? So let's look at here. This is the perpendicular to the base. So vector, let's say vector V is the cross product of A cross B, and this is nothing more than AB sine theta. So the magnitude AB sine theta, the magnitude of vector V is just AB sine theta. And what's AB sine theta? Is the base area. Do you agree? It's the base area. Now, so this is theta. Let's assume that this is the perpendicular direction here. This is vector V. So this is perpendicular to A and B. And there is another angle here, which is phi. So vector V dot C. What's V dot C now? What's C, vector C dotted with vector V is equal to V C cosine phi. But what's C cosine phi? So if you look at this triangle here, let's assume that this is O and this point is P. So O, B, let's assume that this is point C. So this is C. So what's C cosine phi? OB, which is what? The height. Yes, the height of the parallelogram. So in this case, V dot C is nothing more than parallelogram volume is equal to V dot C, and this is nothing more than C dotted with A cross B. Do you agree? Did you have any question? Because B cross C is the base area, and dotted with C is the volume of the parallelogram. Do you have any question? Okay. So if we have vectors A, B, and C are coplanar. So if they are coplanar, i.e. in the same plane, so in this case A crossed with B dotted with C should give you 0. There is another property which is A dotted with B cross C is equal to negative A crossed with B all dotted with C. So what we did here is just we changed the dot with a cross product. So you can interchange without changing any results. So we interchanged the dot with the cross signs without changing results. So far, did you have any question? Did you have any question? Okay. So there is another property which we call it that the scalar triple product does not change under cyclic permutation. What does it mean? It means that if we have A, B, C, it is the same like B, C, and A. So what we did here is just we do a cycle. We brought A in this direction. So you cannot bring A in between. Just you make something like a cycle. So and this is equal to C, A, and B. Again, you bring C here. So C will be dotted with A cross B or whatever, and then this will be equal to negative A, C, B, and this also will be equal to negative B, A, and C equal to negative C, B, and A. So lastly, we will be studying the vector triple product. And in this case, if we have three vectors A crossed with B crossed with C. Let's assume that this would be vector D. So D, let's again represent this here. So this is A, this is B. C, let's assume that this C will be both perpendicular to A and B. So C is nothing more than A cross B. So let's assume that we have another vector, which is D, in this direction. So vector C and vector D, if you cross C with D, so C with D, it will be a vector perpendicular to both C and D. Yes? But vector perpendicular to vector C, A and B are perpendicular to vector C. So the resultant vector should be in the same plane of A and B. Did you understand? So D is perpendicular to A, in this case, and so when I make it here B and C, so it's exactly the same. Let's assume that B and C, which is this vector here, will be somewhere perpendicular to both of them. So when I did it here, I did it A cross B, then I cross the multiplication of A and B with C, with D, but here is the reverse. So it's exactly the same. So D is perpendicular to A and lies in the plane of B and C. So what are the properties of such multiplication? The properties. A crossed with B cross C. And a lot of times people will usually commit mistakes in this one. This is nothing equal to A cross B, then cross with C. So they are non-associative. Non-associative. For the vector triple, scalar triple product, if we have A dot B cross C, it will be equal to A cross B dotted with C. But this is no longer hold here. For the triple product, no longer hold. And you will notice that A crossed with B cross C, A cross B cross C is nothing more than A dot C A dot C is a scalar multiplied by a vector B minus A dot B, another scalar multiplied by vector C. And now you will have, this is scalar and this is scalar. So a scalar multiplied by a vector is a vector, whether you extend the vector or shorten it, and another vector, and this is the subtraction of two vectors. But if we look at A cross B crossed with C, you will notice that this is A dot C multiplied by B minus B dot C multiplied by vector A. Again, so this is why we said that those two things are not the same. Here it is y. So this one will give you a dot c multiplied by b, and this one also will give you a dot c multiplied by b, but look for the second term. The second term here is a dot b multiplied by c. Second term here is completely another vector, b dot c multiplied by a. This is why they are not the same. So by this we conclude with this part of the chapter, and next time we'll be starting the rest of the finishing the rest of the chapter, which will be the geometrical application for vector analysis. Hopefully next week by Monday I will be able to give you the first homework, and it will be due 1 week from next Monday. I think 1 week will be a holiday, will be the 5th of December. So you can give it to me a little bit late, which will be Wednesday. So thank you so much and have a good day.